my work that I've done here. Maybe I'll do that in green. You don't have to show that. I'm just showing you so you know where it comes from. Okay? It's like a balance scale in science when you're measuring things. You have your scale is balanced. When you put your masses on one side and your object on the other, then you know what it weighs. Okay? If we have an equation, it's balanced. If I subtract 5 from one side, then I've got to subtract 5 from the other side to keep it balanced, so my back stays straight, right? So, got to treat each side the same. This one here, circle the term with x in it, get rid of anything else. So that means I'm going to add 4 to both sides. And so I'm left with x over 2 equals 12. The answer to that is not 6. Okay, a lot of students will say it's 6 because they just don't take the time to read what it looks like. It's not 12 divided by 2, it's x divided by 2 equals 12. So what number do you divide by 2 to get 12? 24, exactly. So really, if you're showing work, you're multiplying both sides by 2. Okay. Next one has x's on both sides. You need to get x's on one side, number on the other. So sometimes I look for the smaller x term and I move it, except for the fact if I have just one term with x on one side already, then I leave it there and I deal with the other one. It turns out this is the smallest anyway, but I'm going to subtract 6x from both sides. And so that's 2x equals 14. Then divide by 2. Divide that out, and I get x equals 7. Okay. So that's more than one term with x. Next one, same thing. 2 terms with n in this case. They're on the same side, so just collect like terms to start. So negative 3n. And then you're dividing by a negative. So just remember your integer rules. That divides out. So 15 divided by negative 3 is negative 5. Now. Okay, so the next one, if we have brackets. The odd time you might be able to divide by 3 right away. But really, the best way to do these, so that it works in all equations with brackets, is to expand out. Okay, so multiply that bracket out, so there's no more brackets. Then you want to collect the a terms. Oftentimes I say if there's 2 of them, then subtract the lower one, or get rid of the smallest one, whatever it is, so add or subtract. But if I did that here, then I would have 0 on the right, which is totally fine, but some students kind of forget about that 0. So, just like this one up here, if you have 2 terms with a variable, and one of them is already by itself on one side, then you want to get rid of the other one and bring it over. So, minus 3a, minus 3a. Okay, so that gets rid of it on the left. And you're left with 12 equals, and then 2a minus 3a is just negative a. So that's basically like saying you're going to divide by negative 1, right? Or the opposite side of a gives you 12, so that means a has to be negative 12. But if you want to show that work, that's what it would be, okay? When you show your final answer, I like it best if you put the variable first on the left, equals. So see how this was the number equals the variable, or like the variable equals the number. You can show it either way, it's not wrong, but I kind of likened it to saying, when I say my name is Ms. McKay, right? So my name is Ms. McKay, rather than Ms. McKay is my name. I don't really say that as much, right? And you probably don't either. You say my name is as opposed to something is my name. So this is kind of the same thing. They're both true, but this is a little better form. Okay. So next one. Again, I'm going to expand the brackets, but I'm also going to show it to you the other way as well. In this example, if I expand the brackets, then I only have one term with x in it. So circle that, add 10 to both sides. Okay, and then divide by 5. Okay, so that's going to be, what, 15. Now, this one you could do by dividing by 5 right away. So I'm going to write it out here and just solve it again. So if you have brackets and only a number term on one side, if that coefficient divides into that number, you could do that first. But if it doesn't go in, that means you're going to have fractions, and guaranteed probably something will go wrong. So here, those 5's divide out. So you get x minus 2 equals 13. And then you add 2 to both sides, so x equals 15. Okay. So same, so this is an or. But here, I couldn't have done that, right? Because I can't divide, well, I could go 2 to a divided by 3. Then I'd still have to get the a's together, so you'd be dealing with fractions with a, and it would get pretty complicated. Or way too complicated than it needs to be. Okay? So, those are a review of basically junior high solving equations. If you're struggling with this, you gotta spend some time on your own going through junior high solving equations. I can lead you to some practice. There's tons of worksheets on the internet for solving linear equations. So if you need more practice, let me know, and I'll show you where to find them on the internet. Okay, so now we're getting into solving quadratic equations. Same thing, means the same thing. When you solve an equation, you're trying to find the value of x that makes the equation true. With quadratic, there might be more than one. So for linear equations, there's one answer. For quadratic, there could be 2 answers. Okay, sometimes 1, sometimes 0, and often 2 different answers. Okay, so to solve each of these, the biggest thing is we need for quadratic, which means degree 2, we need one side, oops. Okay. As opposed to linear, where we got the number on one side and the variable on the other, for quadratic, so if you see a squared, and that's the highest exponent on any variable, then you need 0 on the other side. Okay? So the first one is good. It's got 0 there already. So to solve this, you can take a look at it. You can't get x by itself right now. Right? If you solve for this, there would be x on the other side. So you factor. Okay, so when I factor this, 2 numbers that multiply to negative 40 add to 3. So that's going to be plus 8 and minus 5. And now we kind of compare it to when we're looking at the graphs of polynomial functions. Remember how when we're looking for, so if we had, if we were graphing y equals x minus 5 times x minus 8, we learned, x plus 8, we learned that the the x-intercepts would be 5 and negative 8. And it would look something like that. Okay? It was always the opposite sign of the constant term. It gave us the x-intercept. Well, think about what the x-intercept means. That point there has coordinates 5, 0. This is negative 8, 0. The y value on the x-axis is 0. So if I put 0 in here, I'm finding the value of 5 and the value of negative 8. If I put 0 in here, it looks exactly like this. So really, that's what we're looking for, right? When this left side equals 0, that occurs when x equals 5 or negative 8. This is the graph of the corresponding function, okay? This is an equation. There is no y in here, okay? But you can use the graph to help you. So you could graph this y equals this and find the x-intercepts. It means the same thing. Okay. So that's how it relates back to what we did in the end of the last unit. So this next one, Rafa? Sorry, say that again. Well, it's the same process for doing the opposite sign, but remember, that's not in the denominator. So these actually don't have non-permissible values, right? But if you had an expression like this, then your non-permissibles are 5 and negative 8. Those are numbers that you can't have. Here, those are the numbers that we do want, right? So it's basically the same thing, okay, as finding non-permissibles, except now they're not non-permissibles because they're in the numerator. You're actually solving that. So next one, we need everything on the left, and you're solving that. Okay, it's a non-simple trinomial. Krissa? And 4x minus 3. Okay, yeah, that's good. So then when we solve this, it's going to be opposite sign of the constant. If there's a coefficient, it's the opposite sign of the constant divided by that coefficient. Okay, 2 solutions. Okay, take a look at the next one. It's actually not quadratic. You see degree 3. But even if it's here or higher, I'll put degree 2 or higher. So that's a polynomial. Then you still want everything to be 0 on one side. So when I subtract x cubed, I get 3x squared equals, oh, actually I want everything on the left. So I'm going to do all of this at once. So I'll get 4x cubed. Actually, I'll do that. It won't show the steps for it. That's 3x cubed minus 27x equals 0. Okay. So basically, just bringing that over, subtracting it, bringing the 27x over, so it's subtracting, and you have 0. You might think, oh, I'm just going to divide everything by x here. Don't. You'll lose a solution. Don't divide by x wherever possible, or anything with x in it. Okay? Just solve by factoring. If you did divide by x, then you're losing a solution to your equation. And then as well, you're really introducing a restriction, which gets rid of your solution. So Best not to. Just get everything on one side, factor. Turns out I can factor that again. Okay, so really I could have done my factoring work on the side. But that's what it factors to. And then this tells us that there are 3 solutions. Okay, and that's because it's a cubic. So you can have up to 3 solutions for a cubic. Okay, for a quadratic, you can't have 3 different solutions. Well, 3 left. Okay, so here, 0, and then you can remember the short form, plus or minus 3. There's both negative and positive 3. Next ones, now we have a bunch with brackets in them. So take a look at the brackets. First of all, are the brackets exactly the same inside? If they are, then maybe you can do some factoring. But here they aren't. Okay, so I want to expand, get rid of the brackets. The only time we don't get rid of them is if they have the exact same expression inside of them. Okay, so now, once we've gotten rid of the brackets, take a look, it's degree 2, so you want everything on one side. So I try to keep the x squared term being positive, okay? So notice how there's a 3x squared, I keep it on the left. And I'm going to get everything else over. So I'm going to subtract 4x from both sides and add 24 to both sides. Okay, so that this side goes to 0. So these I can collect. That ends up being minus 10x. And then I have that plus 24. Okay, and then you want to factor that. So 2 numbers that multiply to that 72 and add to negative 10. So what's that? 2 and 36. 3, no, it's got to be bigger than that. 4 and 18, no. 6 and 12, no. Maybe there's nothing. 8 and 9, nope. 7, 6, 5, 4. So did I, as long as you check, and you check your work, anyone find factors that work? If there's no factors, then right now, there's no way to find the solutions, okay? There are ways, but we haven't learned them yet. So in this case, if we can't factor, because I checked everything, right? So 14, that's 72. They would both have to be negative to get this. So 9, 81, 8, yeah. Okay, so can't factor. Yep. Did I miss one? What, 19 and what? Not sure? Just start on your calculator. Right? This way you know. So if you go 72, 3 times 4 is 3 times 24 is 72. And then you just divide by 2. Nope. 72 divided by 3. Nope. 72 divided. Just go through all the factors. they both have to be, in this case, negative, because in order to get a positive, they either both have to be positive or both have to be negative. And so there's no way they can both be positive and work. And for negative 10, to get there, it would be like negative 6 and negative 4. It's not big enough, right? Okay. So, can't factor, but when we get to math 20, maybe we can use the quadratic formula. We are going to solve by graphing right now. So if we can't factor it, get out your calculator. Okay, so let's practice. Go to y equals. Okay. And ideally, maybe you should go back to the beginning, but we're going to go to this quadratic first. So the one that we simplified to, and instead of 0, obviously, we don't have 0, we have y, so it's going to be y equals 3x squared minus 10x plus 24. Okay. In terms of a window, fastest way, maybe the last time you graphed something was before we reset your calculator earlier this week. So just check your window. Mine's on a different, it's not negative 10. So I'm going to go zoom and down to standard screen. That goes from negative 10 to positive 10 both ways. If I enter on that, it's going to graph right away. Notice how I don't see it. Okay, so you have to think about, well, what does that mean? Is it opening, is it like opening down and going around that, or up and I can't see it? So think about when we talked about our y-intercept. If we had y equals this, the y-intercept is the constant term. So I want to have a y value of at least 24. So I'm going to go to my window and go to a maximum for y of, let's say, 30. Okay, so that means I'm going to be able to see my y-intercept. So this is going to happen all through high school when you're graphing. You don't always know exactly where it's going to be. You have to work through that window, think about what makes sense in order to graph it, especially when you're at the beginning of learning all of these. And there it is. Okay, I can see it. Does it cross the x-axis? No. So that means there is no solutions. There are no values. So there's the equation. I'm looking for when y is 0. Well, it would have to be down here. And problems are always U-shaped. So it's never going to come back down. So this actually has, it can't factor, but there are no solutions. Okay, so actually, quadratic formula wouldn't help you either. All right. And again, in math 20, we'll learn, do we have to do the whole quadratic formula to know that? No, we're going to learn what a faster way to detect if there's no solutions. Okay. All right. So that's a good little practice using your calculator. Take a look at the next one. We've got some brackets. They're the same. So check if the x plus 3 is in every single term. If it is, you can factor it out. Here, it's in this term, it's in this term, but it's not in the term with 6. Okay, so you can't just factor out x plus 3. This is kind of like saying if we had a squared minus 5a plus 6. How would you factor that? And then you put the bracket x plus 3 back in. Okay. Now, in this case, if you expanded everything and collected like terms, you'd still be okay. Right? Because it's just linear inside there. But let's practice our factoring from the last unit. So this factors to a minus 3 times a minus 2. Okay. And then we substitute our x plus 3 back in for a. And then simplify within those big brackets. So take a look. That's going to be x plus 3 minus 3 is just x. We don't even need brackets. Next one, x plus 3 minus 2 is x plus 1. Okay. So if you had expanded and simplified, you would have got x squared plus x equals 0. Okay? But that means you have to get rid of the brackets a lot and collect like terms. In any case here, solving this, don't forget about the x. It's a factor, 0 and negative 1. Just like when we were doing those non-permissible values. And then the last one there is, we've got a bracket, 2x plus 1, okay, it's squared. No other terms with x in it. With 2x plus 1 in it. But we don't have everything on one side. So first, before I expand this out, I'm just going to see if maybe we can do some factoring by grouping. Okay, so 2x plus 1. I'm going to have the 8 there plus 8x. So basically add 8x to both sides. Okay. And then take a look at it. I've got a factor of 8 that I can factor out. Oops. I've got an 8 that you can factor out of those terms, but I'd be left with 1 plus x. And this is 1 plus 2x. So really, it's not going to help me. I'm going to expand this out now. Okay? Okay, so because of the fact that if I do factor out a common factor here, I still don't get a bracket that's helpful. So I'm just going to expand everything. Okay, and then collect like terms. I'm putting descending order of degree. So it's a non-simple trinomial. So you can use decomposition, trial and error. But I notice that it's a non-simple, but this is a perfect square. Its root is 2x. This is a perfect square. Its root is 3. If I take the product of 2x and 3 and double it, do I get 12x? Yeah. So this is actually going to factor to 2x plus 3 all squared equals 0. Okay, so an equal factor, yeah? Yeah. So this really means you have two factors of 2x plus 3. So you have two solutions, but they're exactly the same. So you only have to list it once. Okay? So sometimes we call it two equal roots or just one root. In terms of what it looks like, let's take a look at it when we graph. Okay, so again, I'm going to go to this here, rather than going to the beginning, and I'm going to enter that graph, or so that equation. So the simplified one, where I have 0 on one side. Okay. I'm going to go back to my standard screen because my y-intercept is 9, right? So the fast way to do that is zoom Z standard, number 6. When we press enter, it's going to graph it right away. And you can tell it just touches the x-intercept once at -3/2. If I trace on that and enter -3 divide by 2, the y value is 0. Okay? So it just touches once. If it doesn't touch at all, there's no solutions. If it touches twice, then there are 2 solutions. Okay? In this case, it just touches once. Even though there's 2 brackets, the brackets are exactly the same. Okay, so that's the end of my examples.